Okay, so I've got some bits and pieces here that will give us an idea of what we're doing. So we've got some lactase, we've got some lactose, we've got the data book. Must be looking at our... we must be looking at some of our saccharides, disaccharides, polysaccharides, and our sugars. I think it's a bit harsh. Okay, so what we're looking at, I've got my data book, is we're looking at our carbohydrates. So what we're using these for in our bodies when we're eating is we're breaking them down into glucose. So we're giving ourselves some energy for respiration. So the fact that everyone isn't eating carbs anymore, I say everyone, I definitely am, but lots of, celebrities don't have carbs. The Rock would not eat carbs. Superhero type people wouldn't, like Chris Hemsworth would probably very rarely touch some of our carbohydrates, apart from the leafy vegetable cellulosey ones. Because what we're doing is we're trying to get some energy through glucose. So what happens is we have glucose and some oxygen, so glucose and oxygen, and it's producing carbon dioxide and water and lots of energy. If we're not using that energy immediately, which we normally aren't, we store our energy. This can be stored either as glycogen or eventually it will be stored as fat. You only really need to be thinking about glycogen, but mentioning that it also can be stored as fat is probably a really good additional fact to show that you understand it's not just glycogen, but you don't need to know that process. So we get our polysaccharide. Mostly we're going to be looking at starches, and then it gets broken down to a disaccharide, then a monosaccharide as glucose. That can then travel around the body. When the body says, no, I've got enough of this, thank you very much, I don't need any more, it then becomes back to a polysaccharide as glycogen, or it can become our fat. So that's our process there. Some enzymes that we need to be thinking about are amylase. Happens in the mouth and it starts to break down the polysaccharide. I think this is the one enzyme I mention all the time. So if you have blood or some protein stain on you, carbohydrate stain it must be, but if you have blood or something on you that's got this in, amylase starts to break it down immediately for you. So if you spit on any blood stains, it breaks it down before you put it in the wash. Then we have sucrase. Sucrase. Sucrase is the enzyme, and it breaks down sugar or sucrose. Lactase breaks down lactose. Maltase breaks down maltose. Cellulase breaks down cellulose. So lose means it's a sugar. Ase means it's an enzyme. 3 years of biochemistry degree, and I'm forgetting these, and a master's, and I'm forgetting which way these go around. So these are the ones that you're going to need to know. These aren't in the data books, but you can get them from their names. The amylase one is not, but yeah, just have to kind of remember. So what we have happening is we're going to look at starch. So all of the examples I saw just looked at amylose as our example of starch. We can say that amylopectin would probably be similar, but I'm going to suggest maybe we'd have different enzymes that worked with this. But all the examples I saw had amylose. So all of the enzymes had amylose being hydrolyzed with amylase and then breaking down further. So, bit of craft for myself. I've got my amylose. Got N brackets either side. because it goes on and on and on. This is me copying from here. I have my links here, just the links, and what happens is my enzyme comes across. Specific, fits into space, lowers the energy needed to break things apart. First one on my list is amylase, and it happens in the mouth. So it breaks my long chains, maybe up to 100, maybe more. Long chains up into disaccharides. So breaking up into disaccharides. So we've added some water, a H on one end, an OH on the other side, because my H has gone over here. Right, now I have something different, because I don't have a long polypeptide. I've got this structure. So I have the one they don't give you in the book. Oh, I love it. So what do you do? No, I've forgotten one over there. This should be maltase. Yeah, so it's not sucrose, because I don't have this down here, this here, no match. It isn't lactose, because I don't have this structure. But it's not cellulose, because that's much longer. It's neither of these. So go back and compare it to my previous terrible drawings. We can see that maybe I didn't. Oh, there you go. That is a maltose. So it's a maltose. So it gets digested kind of in the mouth and the upper digestive system. Maltose now is getting digested in the small intestine. So we've got this maltose, and it needs to be broken up again. So now we have maltase. Ase is the, got maltase. Different to amylase. It's not going to work the same. It's going to detect different things. Right, and then we've got some water as well. So we have our OH here, and we have an H. And then we compare these two. Well, these two, they're the same. So I've got two monosaccharides that are exactly the same. So I can get rid of this one and compare it to my data book. And it's a glucose. So now I've got a glucose. So I've gone from starch through hydrolysis to make maltose, Ase, O's. Oh my god. Then more hydrolysis with the maltase to make glucose. This can then be turned into energy immediately, so that sugar rush, that's a bit of a fallacy, and then can be stored as glycogen longer term. Storage. Maltase, Ase, O's. If in doubt, look at the data book. O's. So that's the one we can all digest. So all of us I'd say all of us, there must be some people who don't fit in, but the majority of the population can digest starch of one form or another. The thing that nobody can digest: cellulose. So cellulose, remember I said this comes from plants. This is the fibrous, tough roughage. So when you have to eat roughage, when someone says you need to eat more fibre, this is what they're talking about. They're talking about more of our cellulose. We do not have cellulase. We're not cows, we're not goats, we're not sheep. So we do not digest this. So we can't break up cellulose. So it goes in and comes out. We don't have anything happening. So that's why it's actually quite useful dietary wise, because it kind of comes out and pushes everything with it. You think of it as kind of a scouring pad for your body. It's taking everything out with it. So cellulose is only really broken down by herbivores, like strict genetic herbivores. We are not genetically herbivores. Then, while I'm talking genetics, our last little bit. So lactose. We are weird creatures that drink milk far longer than any other species. You will not see a middle-aged cow going over to its mother and getting some milk. It just doesn't happen. Slightly weird. So, lactose can be digested if you have your lactase. So lactase is our enzyme. Lactase looks surprisingly like one of my other enzymes, but lactase will come along, break it up, add some water, and now you've got glucose. No, it's not glucose. That's galactose. And glucose. But the problem is, not everyone has this. It drops off the amount you have, and the books don't mention it, but it's also quite a cultural thing. So Western people tend to have more of this because, you know, we've been kind of bred almost to drink milk, whereas people who don't have a cultural thing of maybe drinking milk, they haven't necessarily got these enzymes. Also, you can just lose them when you get old. It gives you like terrible wind and terrible bloating because your body isn't digesting it, isn't breaking it down. It can be kind of a degree of fermentation, so you get lots of gas, trapped wind, feels disgusting. I don't know, I don't have it, but there's lots of ways you can treat it. You can be like a hipster person and just have a different type of milk. You can have lactose-free milk or alternatives. They're much more common now than they ever have been. Or what you can do, I'm going to use these for an experiment later, is you can take these tablets. So you can use lactase. So these are just tablets of the lactase enzyme. So they're just lactase enzyme, and they stop you getting your bloating, diarrhea, cramps and gas. And you just take it, where is my instructions? I can't read. Oh, so you take them before eating anything dairy. So that provides your body with the enzymes that you need. So they're just the enzyme in a powdery form, compressed with some other stuff, and it just kickstarts your body and does the work for you. They must have other binders and things in here, but you can use these. It says take 2 or 3. I'm going to take one. Ugh. Oh my god, they're disgusting. And they taste of mint. So they taste of mint. So you wouldn't want to drink milk after having something minty. That's horrible. Ugh. So I'm going to use these for when we look at enzyme activity, but that's like one of the things you can use if you can't digest lactose, milky products, or you can just use alternatives. They're kind of the two things you can do. Or you can avoid them, I suppose, completely. Just, you know, a bit more vegan diet without any animal products. So that's our carbohydrates. Think about the cutting up of them and what we're doing there. Think about your data book and how the information is in here, and how there's information that you haven't got but you should think about putting in, and then that's going to help you with understanding what happens. Good. So carbohydrates. Have fun.